Hello students, I would greet you by saying good morning. I don't know if it is good afternoon, maybe evening, to each one of you, whatever time you are with us here. Right, I greet you by that. This is another day where we are meeting in mathematics. Remember what we introduced is a new topic about transformation. Previously, by the videos down here, you can use the link. You'll be able to be connected in case maybe you're joining us for the first time. Please revise what we have already done, because here now we're heading towards the end, so that you should be connected, not be left behind. Like previously, we were discussing something about the second type of enlargement. That's the issue about rotation. Right, so by the previous video we had, in case you weren't with us, so I assume I encourage you to do the same by the link down here. We were discussing on how best we can rotate a figure. Say you're given a figure, considering maybe, for example, you see a quadrilateral, ABCD, and you'll be asked to rotate this figure. Whatever, could also be maybe a triangle, talk of triangle, maybe KXQ, right? You'll be asked to rotate any kind of a figure. You can have, maybe talk of, it can be even what you talk of a parallelogram, etc. and what have you. So the issues that you need to consider in rotation, as I highlighted in the previous videos, are just three main faults. One, you need to consider issue about the center of rotation. Should be conversant, talk of the center of rotation, what is it about? And then have to also consider issue about the angle of rotation. And then the other issue that you need to consider is the issue about the talk of the direction of a rotation. Right. Remember, direction can be either negative or positive. So if you talk of the negative, this is related to, and that's the clockwise direction. But if you talk of the positive, this one is related to anti-clockwise direction. So like for example here, we'll be talking of, say, rotating a shape or a figure by an angle of maybe negative 60 degrees. It means you are going to rotate it to the right side. That is a positive rotation, right? That's a talk of the clockwise direction. But if now you're going to rotate a figure with an angle of 60 degrees, that is just like the opposite. It means you are going to rotate towards what? Left side. So that is the talk of the anti-clockwise is a positive angle, but the clockwise is a negative angle. Light, it might look as if the light should be positive, but not in this case. We talk of the positive is the one that go to the left, but the negative is the one that go to the right. So please be familiar with these three main concepts, 1, 2, 3. These are very, very, very important to consider every time we do the rotation. Right, now the moment in time, what we need to do is a simple activity whereby we are going to locate, let's say, a center and come up with the angle of rotation. We are looking at a situation whereby at times in exam, they can sometimes give you the image and the object at the same time. So for example, here we have got a figure of this kind has been rotated to somewhere, and it comes something like, let's talk of something like this. Right? It has been rotated to that position. This is A, B, C, D, E, F. So this is your D, this is your E, this is your C, this is your talk of B, this is your A, this is your F. Right. So which means all these ones will be the image of the those points of this object. So this is your object, this is your image. Now they might ask you, can you locate the center of rotation? Considering this is your object, this is your image. Right. This was rotated about a particular center of rotation using a particular angle of rotation. Right. So they'll be asking you, I come up with the what? Angle of rotation. and identify the center of rotation. So I'd like to discuss that type of situation. How do we record the center which was used to rotate this figure, and now what was the angle of rotation involved? Right, so that is our business of today. Now, to handle this situation here, the first thing that we need to do, I'll first of all take you back where we need to rotate a figure, and then we identify the center of rotation, and also come up with the angle of rotation. Then after, I'm going to convert that equation now, taking that the figure is given and the image is also given. Then I'll have all area that we use to come up with the image, so that if you just have a clear diagrams like this ones here, then we come and look at the strategies that we can use to identify that same center of rotation, and then come up with the angle of rotation. Right. So now, can we look at this problem where we need to rotate a figure, and after we have to convert that question in a different one. Right, so the question that I have here is just straightforward and simple, based on what we have already discussed in the previous video. So let's have the example here. All right, so what I'll ask you to do is you copy the example, because our lab, the space is not all that large enough to accommodate the example and then the explanation here. So we have this K and Y is a triangle. We are asked to locate, that's a triangle K and Y, which is the image of triangle K and Y. And that's a rotation over 80 degrees about O, which is your center of enlargement. This is center of rotation, not enlargement, but center of rotation. Right, so our figure is a right angle triangle drawn like this. Right, this is our right angle triangle that we're going to rotate about O as center. So here is the right angle that is by that represented by that symbol, that is K. This is N, this is Y. Right, that's the question. So here we have got O. Right. So what we do, our activity for today will begin by first of all doing like what we have already done in the previous example of the previous video. Right, so here we are there going to come up with the image of this figure, which is a right angle triangle. We are going to rotate this one using the 80 degrees as the angle of rotation. So by this nature, I'll be able to know that this is a what? If you talk of the direction, this one should be anti-clockwise direction. So we're going to rotate it about O, which is regarded as the center of what? Rotation. Right, so I'll ask you to copy this, or read it, or pray it now and again so that you remember what I'm going to do here. All right, so let me lab this one and create more space, and we do the rotation and come up with the image. Right, so let us have this one here now. Clear, I will draw, and you can also draw the same triangle, any triangle. Don't be mindful about the talk of the length, just draw any right angle triangle on the paper, on the plain paper, but to that position. What we're interested here are just skills on how we can obtain something. Right, so to draw this triangle on the right space like this one. So this one is the right angle at K, as vertex, then here we've got N, and here we've got Y. Let's consider that the center indicated is somewhere here. Right, this is O. Fine. Now, by the skills that we highlighted in the previous video, as on how we can rotate a figure. Of course, this now will be regarded as an object. To come up with an image, we have to take all those basic steps. So what you do is always have to now consider the center, which is O in this case, the vertices of the figure itself, where you are required to connect these vertices of this object. That's the figure. I'll call this one as object. Let me indicate it because I'll be using some terminologies about it. You connect O to Y, O to N, then O to K. Right, that's what we do here. Let me just have this one close here because of the space itself, but we're talking of the same O to Y, O to N, then O to K. With those lines, we're going to come up with the angle that we're going to measure using a protractor, and then with that, we are going to be able to allocate the images of those points, which are the vertices. Where should be the image of Y? Where will be the image of N? Where will be the image of K? And finally, we are going just to connect, and the resultant figure is the replica of that. Because remember, what you have here, the image is just like the figure that is congruent to the what? Object as such. So that's I'm talking of the replica of the object. That is your image. Right, now let us start by connecting O to Y so that we can see the position of the image of Y. So begin by doing this. I'll join this one to Y. That is my line. I call that one as object line. Now the image of Y, to which side and what position will it be? So I'll take my protractor and fix it here at the center like this, and then measure the angle of rotation to be 80 degrees. So I'll be on my protractor to count down angles here, down line of angles. I'll go by 10, 20, 30, 40, 50, 60, 70, 80. So this is the direction where Y should be fixed. That's the image of Y should be fixed. Right, so this is the direction. Now, exactly at what position? So there, as what I highlighted earlier, it means you need to first of all consider the length of O to Y like this, which is 2. So the same distance has to also be captured within the line of 80 degrees like this. So here we talk of this is like 2 centimeters according to my ruler. So I have a mark here like this. Considering that distance, I'll take my ruler up and bring it like this within that line. So my line here, it means I have to draw a line here going like this, like this, like this, up to this level. That is the position of Y. So this is the Y complement. Not complement, but plane. Talk of Y plane. That is the image of Y. So if you're going to measure this angle here, you find that it's always 80 degrees. So it means this Y has been rotated to that position by an angle of 80 degrees, about O at the center of rotation. Now, where is the position of N? Right, talking of the image of N. So you do the same here. You are going to join, that is the O to M, like this. You go to join O to M, as I'm doing here. Look at this. This is my object line. Object line connecting the center and the vertex of the object. So I describe that as object line. So here's my line. It goes like this, like this. It goes up to and as such. So again, I'll use that line to measure an angle of 80 degrees. So I'll put it on top because the rotation here is a positive, meaning that we're going to rotate this shape towards the anti-clockwise direction. So here, the position is here, right? So I have my angle created from this position, right? So I'll count the number of degrees, be like 10, 20, 30, 40, 50, 60, 70, 80. So the direction is somewhere here, right? So as I previously indicated, so here I'll also do the same to measure the distance from here up to that, and I'll find it what. So I'll place my ruler like that. You can even use a pair of a divider, no problem. So I have it here. So considering the distance from O to N, this one, it is this, which is about 5 point something like 5.6. So this is the mark I'm pressing here. So it is here. So if that, it means I'll lay my ruler against that preceding position, which will come like this one, but within this line. So approximately my N must be somewhere here. Within this line, you can see here, this is an image line is going up to that position here. That's the position of N. Right. Remove my ruler, put it down. So this is position of N, and I'll indicate it as N prime. Right. So also the angle here, this angle here is 80 degrees up to this position, and this one again is also 80 degrees. Right. Lastly, let us see the position of K. Where are we going to have K? So it is the same. What I'll do, I'll draw an object line considering O as the center and K is the vertex of the object. So this is my object line, which will go something like this up to that position of vertex K. Right. So I'll also do the same as I've done for Y and N to obtain the image of K. So what am I going to do? I'll rotate that one by fixing my protractor at that center, right? And then measure the angle of 80 degrees. So which means in this case it would be 10, 20, 30, 40, 50, 60, 70, 80. So the position is somewhere here, like that. So what am I going to have then? I'll have a measure of O to K, which is a distance of 3 point something like 6. Look at that. So that line, that measure is the same that is going to allocate the position of K against the angle of measure that is the 80 degrees. So you can see this is the line, a direction of the position of that is K. So we go like this until we reach at that position. So this is the position of K. That's what we do. So what do I have then? It means here is where I'm going to fix up my K. So that is K prime. Right, next, the last, what I'll do, I'll just connect up those vertices, new vertices. K prime, N prime, and Y prime. So what am I going to generate? So if I join that is talk of K to Y, it will be something that will look more like this. And then N to Y, I'll have something that looks something like this. Like that. And then finally, I'll have N to Y like this. Light. So that's it. So at K is here, since the angles are just congruent, since the triangles are congruent, so I expect to have the corresponding angles of the two figures to be equal. This angle corresponds to this one. If that is 90, this is 90. N corresponds to N. N prime corresponds to N. And those talk of Y prime, this angle Y, it corresponds to angle Y prime, like that. So this is our image of that object. So like this one as the image. Right. So if you look at the way this one has been positioned, it tells that this one has been rotated around, or that's the center of rotation at an angle of 80 degrees. So this one again is also 80 degrees, thing like that. So that's it about the rotation. Right. So now here we have got object, which is K and Y, and the image defined as K prime, N prime, Y prime. Right. What we are going to do is just like what I earlier indicated, to say sometimes we'll be given what? An objective and an image at the same time, and they'll ask you to come up with the center of rotation. And also they will ask you again to determine the angle that was used to rotate that object in order to come up with the image as such. Right, so what I'll do here, it will be like the same question, but now I'll just convert it. We have seen this and how we have done it. Now let us now assume that we don't have the center and the angle of rotation is not known. We have the center, we don't have the center, but the angle of rotation is not known. So this is our image we are given, and this is the object we are given. So we're just given two figures here. One defined as the objective, another one as the image, right? This is your object, right? So allow me to create a question for this one. So the question from this one, it'd be like this one, to say, more take like question 2. In the figures, so let me just create a space here for the question. In the figure, we have a triangle K N M, not M but Y. That's the K prime N prime Y prime. We are told is the talk of the image of what? That's a triangle K N Y. Right. After, that is now after A, that's a rotation, that's the transformation. You transform by rotating. The question is simply asking us to locate. Let's say locate, that's the center, and determine. That's the angle of rotation. Right. You can see now the two questions are different. The first one, we were asked to rotate this object to come up the image. So that's what we did. We all had to see the procedures that we have used to come up with this one. So now we're taking for granted that, say, we don't have that question, but now instead we have got this question here. You have, like, say, in the figure, light. In this case, we are trying to consider this figure here. Of course, there are two figures here, right? They say triangle KNY with the primes, considering this one here. They say it's the image of this triangle, that is KNY, after a rotation. Now they ask us to locate the center. Where actually is the center of rotation? Because when this one was rotated, it means it must be a center of rotation. And now what is the angle then of rotation? The angle must be there. Because I also pointed out to say, in rotation, the most important things to consider are center of rotation, angle of rotation, and the direction of rotation. Right. Is it clockwise or anti-clockwise? Things like that. So those ones are determined by the sign being positive, that is now anti-clockwise, but it talk of negative, that is clockwise. Right. Now, let's discuss how we can locate the center. We've got just two figures here. Image, object. Right. Now, where is the center of rotation? And by how much has that figure rotated? So now the procedures for us to locate the center of rotation and come up with the angle of rotation. Let us understand one another one here. Right. I'll be writing these steps here that I need you to consider. So I'll be asking you to do it, because in my case, I don't have enough space that I can do this, but I'll give you a clear explanation so that where you are, you try just have to consider those steps and do exactly until at the end we find ourselves coming up with the solution to this. That's the center being allocated, and finally we are going to come up with the angle of rotation. Right, so here what we are to do, we have the first step. So here I'll have my steps used for explanation. If you can look at this figure, you'll be able to see that this figure is an object, this one is an image. This is an image of vertex n. This is an image of vertex y. The same k prime is an image of k. So what you're going to do there, you are going to connect the vertex of the image and the vertex of this object. Like say, for example, here I'll begin by connecting n and n. I say n prime and n prime. Then you also connect k prime and a k. At least two pairs are enough. Or if you can connect both three pairs, no problem, of the points. This and this one forms one pair. This and this form another pair. Y prime and y form another pair. So at least two. Right, because our aim is to see somewhere the lines which are going to state them here, you have to see them intersecting. So if you have got only two lines, it's okay. The point where they've gone the lines, which I'm going to explain them here, where they intersect, that will be the point which is regarded as our center of rotation. Right, so let me just begin by two pairs here. So I'll ask you to, step one, join that set of k to k prime. So I've chosen k and k. So which means in this case, you have like a ruler, like this one here, joining k to k like this. Look at this one. Step number one. To come up with the, remember, our aim is to come up with the center of rotation and then angle of rotation. So what we do here, you're going to join by that statement, or you can join n and n, or y and y, any. So I'll have k prime connected to k. Object point and the image point. Now, once I've done that, what is the next thing? In attempt to come up with the, that's the center of rotation. What we're going to do now, we are going to produce the, what we call the mediator. It's more like the midpoint of this line. Let's have the mediator of k. So here I'll ask you construct the mediator over that's a k prime k. That one. So what it means here, just about of trying to bisect this line, that is k. If you talk of the mediator, we talk of the line that is passing right away at the middle of this line here. That's the mediator. So here I don't have a protractor, I don't have a pair of the compass, but in your case, you know how to bisect a line. So if you identify the midpoint of that line should right away pass through and must be perpendicular to this line here. Let me explain issue about the mediator. Mediator is just a talk of the line that passes right away at the middle of another line, but is perpendicular to that line like this. So if I've got a line like A, B, if I'm talk of the mediator of AB, it's the line that you're going to construct that has to pass right away at the middle of this line, but it must be perpendicular to that line. So it'd be the line like this one here. If this is the middle of that line, it means we are going to have a mediator that is going to pass right away through like that one. Right. So it's more like you're going to bisect the line or have the perpendicular bisector. In short, that's what it means, a mediator, a perpendicular bisector of AB. So here we are asking you to do that. So you are there to come up the mediator of this one. So the method or the procedures of coming up with the perpendicular bisector, I think you know them. By just work, you need to do that. So here I'll take it for granted that that mediator passes right away at the middle like this one, right? This just like a sketch. So the mediator is this one here that goes down like this. You can even extend it down like that, right? So this is your mediator. So expect here to be right angled. You can name it as with whatever description. Let's have it like HV. You also have to repeat the procedure 1 and 2 for another pair of points. You can have N prime and N, or go for K prime and go for Y prime and Y prime. So let's have the pair from N prime and N. So write it here. Let me lab this part. For procedure according to step number 3. Like just like a repetition of what we've done for 1 and 2. So 3, what you do is you're going to join that is now N prime to N. Right? So I have my ruler. Now here I need a longer one, connecting N and N like this. So I have it like this one. See what I'm doing here? Up to N. Right. So after I have joined N prime and N, as I did joining K and K prime, so what I'll do next is also to do similar what I did for the K prime K. So here I need also to construct the what? Mediator of that is now N prime N. It's a line. This is N prime N. It's a line as we did earlier for K prime, that is K. Right. So mediator, you also talk of the perpendicular bisector of N prime N. Perpendicular bisector. So what will happen is just like if this is a line, you do the construction, you know how to bisect a line, you know how to come up with the perpendicular bisector, follow those instructions. So if you talk of the perpendicular bisector of this line, obviously it will be somewhere there in the middle, but it should be the line that passing through right away at the middle. So just maybe consider that this is the middle part is here, but through construction, you'll be able to identify which is the middle part of that line. So what you have here, it'd be like, let us take that maybe the midpoint is here for N prime N. So what you do is that you are going to draw that mediator and to become like that. So let me have it this way. But now, as you draw, make sure that the two lines which are defined as mediators has to be produced downwards like this, to be extended. In short, they'll go like this. So the first one was the first one was this one. It's going down like that. So mediator of that line, this is just like in assumption, having it that way, that this is also right angled, and also here there are also right angles, and here there are right angles. So this is the mediator of n prime n, and we also talk of this one is the mediator of k prime k. Right. So as you can see here, we have got this mediator and that mediator. Just try enough. We can even go further and also have the mediator of y prime y, no problem. What will happen, just like when you extend those mediators or produce, they're going to intersect somewhere, right? At one point, they're going to intersect. So here, what you do for point number 5, just like how to produce the mediators until they have to intersect at one point. You have to produce the mediator. This is mediator. Right. So this is the mediator. That's the mediator. I produce them. They are going to intersect here. So this point where the mediators are going to intersect, that is your center of rotation. Center of rotation. Right. So this is the way we do to come up with the center of rotation. Join the image point with the object point. Come up with the mediators. You do for 2 pairs. It's enough. And if you're going to do the other one, you find that also later on, it also going to pass through that same point. If I join y prime to y, and my mediator comes right away at the middle here, you find that this one, as far as this one is 90 degrees, something like that, you'll be able to see this one also passing through like that one, as that one is the mediator, it goes like that. Right. So that's the way we come up with the center of rotation. Finally, how do we come up with the angle of rotation? Angle of rotation, angle of rotation. How do we come up with the angle of rotation? So, to come up with that one is much simple. It's more like the opposite of what we've been doing when we were coming up with the image. So it's just like those some procedures within the same procedures we are going to follow in order to come up with the angle. So like say when we are rotating an angle, it's more like that. What are we doing? So we find ourselves connecting the center and any object point. Like in this case, we connect O to Y. You can choose connecting O to Y, or connecting O to N, or connect O to what? To K, where your O is your center of center of what? Rotation. So I'll choose either to connect O to N or O to K. These are the objects. Or first, come up with the object line. You can choose any one of the 3, because here you are likely to have 3 object lines, one O to Y, or O to, that's the N, another one O to what? To K. Let me choose OY. So this is my object line I choose. It goes like this. Right. So once I've drawn the line from O to Y, I need to also draw another line connecting O to Y prime. If you choose O to N, then you have to also draw another line right away from the center as connecting to, let's say, to N prime. So just like the object line versus the image line of the same vertices. So you draw the line connecting center to object line, and again center to image point. This is object to talk about image point, sorry, object point, or to object point, and or to image point. So once I've done this, you join to that, and this one is also connected to Y. So it's just like Y versus Y. The angle that is created in between the 2 lines here, this angle, that is your angle of rotation. So remember, object point, image point. The 2 points must be connected with the center. So you have the line OY, another line OY prime. So the angle created between the 2 lines, that's the angle of rotation. You can prefer maybe to join O to N, and then should be O to NY. So the angle between the 2 lines, that will be the same angle that we're going to produce when you have started with what? That's a OY and OY prime. Right. So you have this angle here, and you just take your protractor and then measure it and find out its value. So you find that the angle that is there will be approximately equal to what? 80 degrees. This is my sketch, but you have to do, I think you have already done it exact right. So that's it about it. Angle of rotation, center of rotation. I repeat, for the angle, connect the center which you have produced to the object point, and that same center you have located to the image point. Y versus Y. The two lines in between, there's an angle formed. That angle, you just take your protractor and measure it out, and the angle you obtain from there, that is your angle of rotation. So in this case, it's likely you need to get what? 80 degrees. As much as you can see that this object is rotated to your left, that is anti-clockwise, and the angle of which must be positive. But if it be rotated to the right, it means the angle would have been negative. So here attach a positive. Right, so I think for today, let us stop here in this video. We are going to meet again in the other video where we're going to discuss another type of the transformation, which is probably the last in this topic, thus enlargement. So please, I request you to go through these two types of transformation we have so far discussed. One being it the issue about translation, and finally the one that we have just done here, that's about the rotation. Thank you very much for being together this time around. Thank you.